Electrical safety awareness training. Electricity, movement of the free electrons between atoms, related terms. Current, the movement of electric charge. Resistance, opposition to current flow. Voltage, a measurement of electrical force. Conductor, substances, such as metals, that have little resistance to electricity. Insulators, substance, such as dry wood, rubber, glass, and bakelite, that have high resistance to electricity. Grounding, a conductive connection to the earth which acts as a protective measure. Take electricity seriously. Electricity is the second leading cause of death in construction. Electrocutions make up 12% of construction fatalities annually. Over 30,000 non-fatal shocks occur each year. Over 600 deaths occur annually due to electrocution. Electrical hazard, be safe. Burns, electrocution, shock, arc flash, an arc blast, fire, explosions. Types of burn. An electrical burn is a skin burn that happens when electricity comes in contact with your body. When electricity comes in contact with your body, it can travel through your body. When this happens, the electricity can damage tissues and organs. Electrocution is fatal, meaning to kill with electrical shock. Electrocution. Electric current can cause injury in 4 ways. Cardiac arrest due to the electrical effect on the heart. Muscle, nerve, and tissue destruction from a current passing through the body. Thermal burns from contact with the electrical source. Falling or injury after contact with electricity. How shocks occur. Shock occurs when the body becomes a part of the circuit. Current enters at one point and leaves at another. Shocks occur in 2 ways: contact with both conductors, contact with one conductor, and ground. Using a 120-volt circuit, and resistance for wet and dry skin, remember. 1 amp equals 1000 milliamps. Severity of the shock depends on amount of current, path through the body, duration of flow through the body. Depend on electrical shock, severity, and effects of an electrical shock depend on a number of factors: pathway through the body, amount of current, whether skin is wet or dry, etc. Water, great conductor, allows current to flow more easily in wet conditions and through wet skin. Current reaction chart. 1000 milliamperes equals 1 amp, therefore 15,000 milliamperes equals 15 amp circuit. Current reaction below 1 milliampere, generally not perceptible. 1 milliampere, faint tingle. 5 milliampere, slight shock felt, not painful but disturbing. Average individual can let go. Strong involuntary reactions can lead to other injuries. 6 to 25 milliamperes, women, painful shock, loss of muscular control. 9 to 30 milliamperes, men, the freezing current, or let go range, individual cannot let go, but can be thrown away from the circuit if extensor muscles are stimulated. 50 to 150 milliamperes, extreme pain, respiratory arrest, severe muscular contractions. Death is possible. 1000 to 4300 milliamperes, rhythmic pumping action of the heart ceases. Muscular contraction and nerve damage occur. Death likely. 10,000 milliamperes, cardiac arrest, severe burns, death probable. Arc flash, an arc blast, arc flash, sudden release of electrical energy through air when a high voltage gap exists, and there is a breakdown between conductors, gives off thermal radiation, heat, and bright light. Temperatures as high as 35,000 degrees Fahrenheit. Arc blast, an hazard of an arc flash, and blast, arc blast, high voltage arcs can also produce considerable pressure waves by rapidly heating the air and creating a blast. Hazards of an arc flash and blast. Shrapnel, arc flash, and blasts spray droplets of molten metal at speeds that exceed 700 miles per hour. That can easily penetrate standard personal protective equipment, PPE. Extreme temperatures, arcs produce some of the highest temperatures recorded on Earth, up to 35,000 degrees Fahrenheit, which is 3 times the temperature of the Sun. Sudden air expansion, all known materials are vaporized at this temperature. The rate of expansion is comparable to a pea-sized piece of copper expanding to the size of a boxcar. Blast pressure waves have thrown workers across the room. Fatal burns. Fatal burns can occur even when the worker is several feet away from the arc. Clothing can ignite from 10 feet away unless proper PPE is used. Hearing loss. An arc blast can have a sound magnitude of 140 dB 2 feet from the arc, and can cause permanent hearing loss. Fire. Most result from problems with fixed wiring, problems with cords, plugs, receptacles, and switches also cause electrical fires. Fire explosions occur when electricity ignites explosive mixture of material in the air. Defective extension cords. Unsafe behavior. Electrical protection methods, inspect portable tools, and extension cords. Electric hand tools that are old, damaged, or misused may have damaged insulation inside. Use power tools and equipment as designed. Follow tool safety tips to avoid misusing equipment. Follow manufacturer's instructions. Tool safety tips. Never carry a tool by the cord. Keep cords away from heat, oil, and sharp edges. Disconnect when not in use, and when changing accessories such as blades and bits. Don't use in wet and damp environments. Keep working areas well lit. Ensure that cords do not cause a tripping hazard. Remove damaged tools from use. Use double insulated tools. Use gloves and appropriate footwear. Store in drier place when not using. Employer requirements to protect workers. Ensure overhead power line safety. Isolate electrical parts. Supply ground fault circuit interrupters, GFCI, protection. Ensure power tools are maintained in a safe condition. Ensure proper guarding. Provide training. Enforce LOTO safety-related work practices. Ensure proper use of flexible cords. Ensure proper identification of power sources. Safe work practices. Lockout and tag out. Replace damaged cords or plugs. Follow lockout tagout, LOTO, procedures. Lockout tagout, essential safety procedure, protects workers from injury while working on or near electrical circuits and equipment, prevents contact with operating equipment parts such as blades, gears, shafts, etc. Manpower and workers. Qualified electrician, preferably B license holders. Identification of the electrician, example, red helmet, isolation, examples, panel boards, generators, large motors, should be enclosed. The switch should be connected in phase only, the switches should be easy and free to operate. Body of the metallic switches should be earthed. Every dB should be provided with a on and off switch. Guarding, electrical device, any parts of electrical equipment, at 50 volts or more must be guarded. At least 8 feet above the floor of the work area. Grounding. Looking machines. An equipment's entry accessible permission only to qualified personnel. Electrical protection devices, safety device, fuses, circuit breakers, and overloaded trippers. ELCB, GFCI, MCB, earth leakage circuit breaker, miniature circuit breaker. Use ground, fault circuit interrupters, GFCI, designed to protect people from electrical shock. Limits duration of electrical shock. 3 types of GFCI, receptacle GFCI, temporary, and portable GFCI, circuit breaker GFCI. Receptacle GFCI, often found on contraction work sites, outdoor areas, and other locations where damp conditions do or could exist. Temporary or portable GFCIs. Temporary or portable GFCIs are frequently used in construction and in outdoor settings with electric tools, mowers, trimmers, and similar devices. Circuit breaker GFCI. If a person's body starts to receive a shock, the GFCI senses this and cuts off the power before he and she can get injured. Maintain safe distance from overhead power lines. Contact with overhead power lines. Overhead power lines carry extremely high voltage. Risks: electrocution, burns, and falls. Voltage: nominal, kV, alternating current, minimum clearance distance, feet, up to 50, 10 feet, over 50 to 200, 15 feet. Over 200 to 350, 20 feet, over 350 to 500, 25 feet, over 500 to 750, 35 feet, over 750 to 1,000, 45 feet, over 1,000, as established by the power line owner, operator, or registered professional engineer who is a qualified person with respect to electrical transmission and distribution. Hazard and protections: hazards, unsafe wiring, exposed electrical parts, wires with bad insulation, ungrounded electrical systems, and tools, overloaded circuits, damaged power tools, and equipment, using the wrong PPE, and tools, overhead power lines. All hazards are made worse in wet conditions. Damaged extension cords, unqualified workers doing electrical work, protective measures, proper grounding, use GFCIs, use fuses, and circuit breakers, guard live parts, lockout, and tag out, proper use of flexible cords, close electrical panels by competent person, employee training, ensure competent person on site, use proper approved electrical equipment, qualified person installs electrical devices. Employer requirements to protect workers, ensure overhead power line safety, isolate electrical parts, supply ground fault circuit interrupters, GFCI, protection, establish and implement an AEGCP. Ensure power tools are maintained in a safe condition. AEGCP equals Assured Equipment Grounding Conductor Program. GFCI equals Ground Fault Circuit Interrupters. Electrical tools, gloves, used to protect, and comfort hands against cold or heat, damage by friction, abrasion, or chemicals, and disease. Wire and cable lugs, used for connecting cables to electrical appliances, other cables, surfaces, or mechanisms. Line tester, used to test the presence of current, and to identify phase and live wire in electrical installations. Conduit bender, used to bend electrical pipes for installation. Coax connector, used for connecting cables to electrical appliances. Other cables, surface, or mechanisms. Voltage tester, used primarily on AC currents, although some can also be used on DC currents. Wire strippers, used for removing the protective coating of an electric wire in order to replace or repair the wire. Solder capillary lead, free wire, used to produce perfect joints quickly and effectively. Stubby screwdriver, used to facilitate access to screws located in areas that cannot be reached easily by a regular screwdriver. Pliers, used for gripping. Crimpers, used to make cold weld joints between wires, and a connector by deforming one, or both of them to hold the others. Electric drill, used for drilling circular holes in the materials. Flashlights, used to provide a source of light at a time of night. Rescue rod and hook, used to remove persons incapacitated by electrical shock from the danger area. Cable ties, used for holding items together, most commonly electrical cables or wires. Electrical tape, used to cover and insulate a broad range of cables, wires, and other materials that conduct electricity. Fishing rods, used to install wires above coulings, in attics, through walls, etc. Hacksaw, used for cutting thin metals such as aluminum, brass, steel, or copper. Tape measure, used to measure distance or size. Heat shields and pads, used to protect objects from overheating. Level, used to determine whether a surface is horizontal, level, or vertical. Plumb, terminal block, used to secure or terminate wires. Goggles, eye protection. Flux brush, used for connections that are joined together by soldering. Super fire torch, used for soldering and brazing. Fish tape, used for pulling electrical or other wires through conduits. General safety rules for all power tools: keep work areas clean. Cluttered benches invite accidents. Avoid dangerous environments. Guard against electric shock. Prevent body contact with grounded surfaces. Avoid accidental starting. Don't carry plugged-in tool with finger on switch. Hand tool general safety rules: do not use a power hand tool while wearing wet cotton gloves or wet leather gloves. Never operate electrical equipment barefooted. Wear rubber-soled or insulated work boots. Do not operate a power hand tool or portable appliance that has a frayed, worn, cut, improperly spliced, or damaged power cord. PPE. Basic PPE consists of cotton protective clothing with long sleeves, helmet, or hard hat. Goggles for eye protection, gloves, leather, or rubber, hearing protectors, safety footwear, protective equipment for arc flash, flame-resistant protective clothing, arc flash protection hood, helmet, safety glasses, gloves. First aid for electric shock victims: don't touch them, unplug the appliance, or turn off the power at the control panel. If you can't turn off the power, use a piece of wood, like a broom handle, dry rope, or dry clothing, to separate the victim from the power source. Do not try to move a victim touching a high voltage wire. Call for emergency help. Keep the victim lying down. Unconscious victims should be placed on their side to allow drainage of fluids. Do not move the victim if there is a suspicion of neck or spine injuries unless absolutely necessary. If the victim is not breathing, apply mouth-to-mouth resuscitation. If the victim has no pulse, begin cardiopulmonary resuscitation, CPR. Then cover the victim with a blanket to maintain body heat, keep the victim's head low, and get medical attention. Then, check for breathing as follows: look for the rise and fall of the chest. Listen for the sounds of breathing. Feel for air on your cheek. Carry this out for up to 10 seconds. First aid for electric shock victims. First step, second step, third step, fourth step, fifth step, sixth step, seventh step, eighth step, ninth step, 10th step, 11th step, 12th step, 13th step, 14th step, 15th step. Uses of fire extinguisher. Extinguishing method. 1. Pull the safety pin. 2. Aim the nozzle to the fire. 3. Squeeze the handle's discharge. 4. Sweep the nozzle from side to side. Remember, safety distance between you and the fire flames is 6 to 8 feet. Workplace fire safety tips and fire orders. Identify the fire hazards, identify the people at risk, evaluate and reduce hazards, set up an emergency plan and conduct training. Review risk assessments. What is electricity? A. The movement of atoms within an object. B. The movement of free electrons between atoms. C. Solid mass. D. Movement within the nucleus of an atom. Answer. B. The movement of free electrons between atoms. Arc flash. An arc blast can reach maximum temperatures up to 350 F. A. True. B. False. Answer. B. False. Temperatures can reach up to 3500 F. What does GFCI stand for? A. Ground flexible conduit insulator. B. Ground flow current interceptor. C. Ground fault circuit interrupter. D. Ground floor connection interjector. Answer. C. Ground fault circuit interrupter. Which of the following is a safe practice? A. Carrying power tool by the cord. B. Holding fingers on switch button while carrying a plugged-in tool. C. Keeping cords away from heat, oil, and sharp edges. D. Yanking cord to disconnect plug from outlet. Answer. C. Keeping cords away from heat, oil, and sharp edges. Who is responsible for ensuring that overhead power lines are de-energized? A. Power company. B. Employer. C. Employee. D. Municipality. Answer. B. Employer.